Hello students, last time we have seen the characteristic equation for DC shunt machine, wherein we have derived the relation between speed and torque. So it was a straight line equation having y-intercept V by K, where V is the applied voltage to armature, K is motor constant, which depends upon number of conductors, then number of poles, number of parallel paths in particular motor. Then there was a slope of the characteristic, RA by K square into torque. So this was a straight line equation in the form y equals to mx plus c, where slope is negative, slightly negative, almost zero. So you can plot this curve by taking speed on y-axis and torque on x-axis. So this point is y-intercept to V by K and a slight negative straight line. So okay, this was some revision, what we have seen in the last lecture. So from this characteristic we can figure out how will be the characteristic when we change parameters of the machine to control the speed. So we know that torque is not in our hand. We cannot change the torque because it is the demand of the load. So, and this K, motor constant, also we cannot change. So only variation possible is we can change armature circuit resistance and armature voltage. Therefore there are two methods only to control the speed, that is armature resistance control method and voltage control method. So in this regard, there will be variation in the V and there will be variation in the armature circuit resistance. So if I draw the characteristic for that variation, so there is natural characteristic of the motor and with change in the parameters. So when we change V, only the V by K, the y-intercept point will get changed, slope will remain same. So due to that, all the characteristics will be parallel to this characteristic. So as we change V, this point V by K will be shifting. So we will get some shift in the characteristic. So for V by K it is a natural characteristic, this is no load speed. Then we change the V1K, and what change we can make? We can just reduce the V, we cannot increase the V because it will be like giving over voltage to the motor. So we can give smaller voltages to the motor, and due to that the characteristic can be shifted only downwards in this direction. So again, if we change V, it will be like this. So in this way there will be change in the V. So even though there is, you can say, reversal of the torque, negative torque, so even that case the same characteristic equation works, because there is no change. If we substitute negative values of t in the same equation, okay, in the same equation, if we put negative values of t, slope will still remain negative, y-intercept remains same. So we can say that this characteristic will get extended into the second quadrant. So it will get extended to the second quadrant. So we can say that whatever is the slope, that also has not changed, and y-intercept also has not changed, wherein just negative values of torque are substituted in the same equation. So the characteristic will get extended into second quadrant with the same slope, with the same y-intercept. So in that way, this is the characteristic, or this could be the operating range of the motor, isn't it? Then what is the meaning of minus T? Practically, minus T means electrical braking. So by any means, if we make torque of the motor negative, in that case motor start operating in braking. And what type of braking is this? So we can observe, if operating point, normal motoring point is here, suppose point A, normal operating point in motoring mode. We know the four quadrants. So this is a motoring quadrant, this is braking quadrant, and if we consider this speed as positive, then it is forward motoring and forward braking quadrants. So if by any means speed of the machine increased and go on beyond no load speed, see, speed at this point is more than no load speed even, whereas normal operating speed is less than no load speed. So machine runs with speeds more than no load speeds, higher speeds. In that case, there is possibility of negative torque. So this is, if this is the operating point, then motor will be running with some higher speed and some negative torque, braking torque. So this is braking quadrant. So how is it possible that motor runs beyond no load speed? So this is possible only when load drives the motor. So there are many loads which have tendency to accelerate the motor or to drive the motor. So in that case only there is possibility that the motor can be running beyond no load speed. That is a braking quadrant. Similarly, if we vary the voltage, so what will be the range of characteristics? So we already know that for particular voltage there is different y-intercept point. So whatever is true for natural characteristic, that is also true for the other characteristics when we change the voltage. So if this is the natural characteristic, then this point is V by K. Then for a different voltage, this could be the characteristic. For another voltage, this could be the characteristic, like that. In this direction, V is decreased. Okay, in this way we can achieve any operating point in some this region, any operating point. It depends how smooth we vary the voltage. We can vary the voltage. Then you can say the limit of speeds and torque that we must talk about, because only drawing some lines in the axis will not give the practical, you can say, practical application knowledge. Okay, so this higher speeds beyond no load, they could be twice as that of the rated or like that, but you can see as the characteristic slope is very small, with the natural characteristic it is very high torque produced in the machine to get the double speeds and like that. We know that motor is designed for double the torque, isn't it? Normally current could be double that of the normal rated current. That means whatever is the operation, whether it is starting, okay, see this is starting point, when the speed is 0, there is some torque, so this should be a starting torque. So at the max this could be double that of the rated. Current in the machine can be double that of the rated, so torque also can be double that of the rated. So whether it is a motoring operation or a braking operation, these are limits of the torque or limits of the motor current. So whatever is the dynamic condition, change in the speed, braking, starting, the torque cannot be more than this. Okay, current through the motor cannot be more than this. So whatever is the speed related to this torque, this could be the maximum speed of operation. So what is the range of operation in braking? So more than no load speed and up to this speed only. This is the range of operation for motor when we keep torque in safe limits. So in braking it is a very narrow range, whereas in normal motoring it is a wide range, right from 0 speed up to no load speed we can operate, whereas for higher speeds it is very small range. Okay, so this is regarding limits on the torque. Now what are the limits on the speed? So limits on the speed are decided by the bearings, the motor shaft bearings, because for higher speeds what component of the machine will get affected? It is the bearing friction. So bearings are designed for particular amount of friction. So if the rated speed of the bearing is exceeded, in that case bearings will get overheated and their life will get reduced. They may get damaged like that. Okay, so that is the limit of the speed which is decided by the bearing. It is also generally good bearings are designed for like double speed. Okay, or the motor manufacturer which uses the bearing, so they use the bearings which are having rating double that of the rated speed of the machine. So you can go for double speeds, but we have to see the electrical side parameters to go beyond no load speeds and going for double speed and like that. Okay, so all the precautions in the electrical side is if maintained, then mechanically the machine can deliver the required torque and speed like that. So this is regarding limits on the torque and the speed. So this was variation in the V. Similarly, there could be variation in the armature circuit resistance also. In that case, what will be the change? So in that equation, omega m equal to V by K minus RA by K square into T. So again, armature resistance cannot be reduced. So slope cannot be again less than slope calculated by this RA by K square. So it cannot be less than that one. It can be increased. It can be increased by adding external resistance into the armature circuit. So now the resistance term, the term in the numerator is now higher. So due to that, slope will be again higher. So y-intercept point remains unchanged, V by K. So this is the point in the y-axis through which characteristic cuts the y-axis, isn't it? So that point remains the same, and whatever are the values, those decides values of the external resistance, those decides the slope of the characteristic. So in this case, it will be multiple characteristics passing through this point. So multiple characteristics having multiple slopes. So again, I'll take motoring as well as braking quadrants. So if this is the natural characteristic means with the standard rated motor parameters, nothing is changed. Okay, nothing is inserted into the armature circuit, or voltage is also a standard one, like that. So this is a rated operation, we can say, natural characteristic. Now if we add resistance externally, so obviously natural characteristic means this is with R equal to 0, external resistance 0. And if we add external resistance, then there will be another characteristic, okay, slight increase in the resistance. So another characteristic passing through the same point, isn't it? Same y-intercept. Then one more characteristic for further increase in the external resistance. So like that, there could be multiple characteristics. So what is the effect on motoring side and braking side when we insert this resistance? So on motoring side, okay, as well as on braking side, as slope is increased, some small change in the torque will result in the small change in the torque result in the large change in the speed. Okay, so this is the change in the torque, and here is the change in the speed. So this has you can say become like more unstable. Okay, naturally the characteristic is almost flat one, so the speed is not getting much affected by change in the torque, whereas now it has become more sensitive to the changes in the torque. So that is the one, you can say, effect of inserting resistance externally to the motor circuit. Whereas regarding range of the speed, there is effect. So previously with no resistance in the rotor circuit, in the armature circuit, this range of speed beyond no load was very narrow, very small. So for the same amount of torque, braking torque, we can say the same amount of braking torque. See, for larger resistances higher speeds will be achieved. Again, somewhat small resistance, somewhat lower speed is achieved, and again somewhat lower speed, like that. So for the same amount of braking torque, the speed achieved could be higher. Okay, that is the effect of adding external resistance into the armature circuit, okay, in braking quadrant. So in this way we can summarize, okay, this effect of armature circuit parameters on the motor operation. So after this shunt and